Okay. All right. So my name is Henry Lieberman. I'm at MIT Computer Science and an AI lab, and this represents the thesis work of my student Karthik Dinakar, who was at the Media Lab, and he's now at Brigham and Women's Hospital in Boston. I always love this quote from Alan Kay, who says, "Point of view is worth 80 IQ points." And I think point of view is very important in thinking. And if you have somebody who has a very good point of view, they know what to think about, what the most important things are, not to pay attention to things that aren't important. They have a library of solutions and great way of thinking about problems. So Alan has given me a lot of interesting point of views. And in machine learning is very good at aggregating data, putting large amounts of data together, okay? But I think that people don't appreciate when data comes from people as opposed to data that you might get from scientific instruments or something like that. Point of view becomes very important. The difference is that when you get data from instruments, the instruments don't get a vote. But when you get data from people, the people do get a vote. So I think we need to study point of view, okay? And the problem with machine learning is that it's kind of like making a smoothie in a blender. You know, you put a lot of vegetables and fruits in the blender, and then you hit puree, and you get a tasty smoothie, but kind of the individual components are sort of lost. Okay, and there's no way to incorporate different perspectives and stuff. And I think Ernie's talk was a great lead-in for this, because thinking about, you know, machine learning, a lot of learning is closed world. So this is a way of opening the world a little bit. Okay, so we got started on this work when we were trying to work on the problem of cyberbullying on social networks. So we had a bunch of posts on social networks, people talking about their experiences, and then it was annotated by the moderators of the groups. And we were kind of really struck at how different points of view were on that. So the teenagers, so, you know, maybe you had two guys arguing over a girl, and then, you know, the teenagers thought this is teenage drama. But then when the adults looked at it, they said, oh my God, this is serious bullying. And when the psychologists looked at it, you know, they had a different viewpoint that was much more technical. So we kind of set out to try to capture the notion of point of view. Okay, and we're thinking about different kinds of people. Okay, so if you get the initial data, then any kind of annotation that you have on the data or the original data itself kind of gives you a baseline view. And that's good because, you know, it's big data, you got a lot of it. But the problem is, again, the points of view are all mixed up and it's hard to identify them. Okay, and so we thought about, you know, having a smaller number of people who we call informants. In a medical setting, the patients might be the annotators, or the patient chart has annotated information in it, okay? But then you have the doctors or medical researchers, or it even could be that a subset of the patients. And they might have unique and valuable perspectives. They might know stuff that isn't in the medical chart. They might be able to explain why things are interpreted in a certain way. Okay, so what we want to do is use this lensing technique to kind of amplify their perspective, so that the informants don't have to go back and annotate all the original data, because that's what you have to do in standard machine learning. Okay, so I want to give you some news hot off the presses. We did a project that was looking at male and female points of view in cardiology. We analyzed doctor-patient interviews. Okay, and the issue there was to try to understand if there were differences between the way men and women reported cardiac symptoms, or if it was reflective of some kind of underlying illness. Okay, and with our medical collaborator, Catherine Koutsoulis, we were able to show that men and women express cardiac symptoms a little bit differently, but the underlying disease is the same. And that led to a change in the cardiac diagnosis guidelines by the American College of Cardiology and the American Heart Association. They directly referenced our work in showing this. And I think this change is going to result in saving thousands or perhaps millions of people's lives, because there's a higher misdiagnosis rate of cardiac problems in women. And we were able to show that, and they now say that the angina, which is chest pain, should not be described as atypical, which was the description that they were using for the way women tended to describe their cardiac pain. So this is a great victory, and it just happened recently, so we're very happy about it. So lensing can be thought of as a form of knowledge acquisition. So in machine learning, you want to learn from the data, okay? But you also want to be able to leverage expert knowledge and maybe the knowledge of a minority of the data, okay? And then, in some sense, talking to experts is like traditional expert systems, but we all know the problems of 1980s and 1990s expert systems. They were brittle, it was hard to scale them. Many of the scaling problems have been addressed by machine learning. But what we want to do is both learn from the data and learn from different perspectives. So we have a mixed initiative workflow. So the mixed initiative workflow says you run a machine learning analysis according to some model, okay? Then the informants critique the model by example. You can't ask them to give weights on a neural network or tune hyperparameters. So you have to go back to the original examples and then infer from the examples what the changes to your model should be. So we have a lens, a representation of what that perspective is. It's a matrix. It's represented as a matrix. I don't have time to go into the mathematical details, but one way to think about it is it's kind of like affine transformations in computer graphics. So in computer graphics, you have a matrix that can represent rotations, translations, stretching and shrinking, skewing and perspective and so forth. And so if you package up the transformations into this object, then you can mix and match the transformations. And so we can mix and match lenses and points of view, and that's very helpful. Okay, so here's a little bit of a complicated diagram of how it worked, but I'll try to explain it quickly. Just focus on these blue dots here that show you the steps. So these things are diagrams for latent Dirichlet analysis. These are variables. The arrows are conditional probabilities, and the boxes are iterations. These are the priors, and so forth. So what we do, you don't have to understand how all this works, but basically it's topic modeling. So we analyze some natural language. We get a weighted list of keywords that's supposed to say what this is about, okay? Then we have various ways of presenting a cognitive task to the informant that doesn't ask them directly about it, but sees what words they use or analyzes natural language that they provided, right? So, or we give them a little task like make a sentence out of these words to describe this situation, okay? And then we come up with a mathematical lens which represents the transformation that comes of account of that. And we basically treat it as another observable variable that goes into the probabilistic computation here. Okay, and then I'll show you how that's used in the application. Another application that we did was to make an assistant for people on a crisis text line. Okay, I got a minute or 2 minutes. 1 minute. Okay, and so what we have is here's the text conversation. Each word gets filled into some probabilities of various topics, and then and we got these topics by asking psychologists and counselors on the lines to go through, and we made a lens that that represents the perspective they have in dealing with the client conversations. What we're able to provide them is, as the conversation goes along, we have a real-time display of the relevance of each of the topics to the current conversation. So if somebody's talking about self-injurious behavior, well, that could be alarming. So you want to look back and see where else in the conversation has that occurred. So here it hasn't occurred recently, so maybe it's not so serious that we have to call the police, but then there was a previous incident. If you click on these red dots, the counselor can go back to the previous conversation to see what's going on. So to summarize our contributions, we introduced lensing, which is a first-class representation for perspective or point of view. We showed how to use it in a mixed initiative workflow where we do some machine learning analysis, the informants critique it, and then we can stick it back in the analysis. And this is great because it works with many different machine learning methodologies, and it can be applied at various stages in the machine learning pipeline. And finally, we implemented some very impactful real-world applications in cardiology, in crisis counseling, and other mental and physical health applications that you can find in the paper. Thank you.
Thank you. Perfect. I have a question, or just one of the doubts I have. How does this method differ from the human in the loop machine learning or training?
It's a kind of human in the loop machine learning. Amershi and others. So we're part of that. We fully sign up to that movement.
Gotcha. And does that lens get a special treatment? Does it get, I mean, do you just train on this new data point, new observation that human provided as this lens concept?
Well, no, see, the problem is that there aren't very many informants and there's a lot of data, right? So the idea is that by asking a few people and getting a little bit, then you amplify that perspective. Okay, so roughly what the lens represents is the difference between the data's perspective and the informant's perspective. So you can approximate how the informant would have thought about all the data by by using that lens.
Gotcha. Yeah, that's what I was wondering.
Yes.